Christian radio talk show host Bob Dutko did a presentation, or rather a sermon, in a church a year or so ago, in which his presentation included what I recognized to be like different categories of things that he was getting wrong, typical creationist claims. And I thought I could make individual episodes out of all of these, where he would talk for a minute or two about radiometric dating and get all that wrong, and a minute or two about getting something else wrong. And on occasion, I would bring in experts to help with the various topics, or people in the know on those. And in this episode, all I have to address is one sentence, one thing he said alone, but it's worth its own episode anyway. It's when he claimed that the Earth can't be as old as paleontologists and so forth say it is, because
dinosaur bones have been discovered now with soft tissue inside.
Erica, you are a paleoanthropologist. You are of course, paleontologist. You've been to Africa a number of times. You know how fossilization works. You know quite a lot about the creation evolution issue, right? And I saw a video that you did where you had read up on Fossilization and a lot of other things about dinosaur soft tissue. So I wanted to ask about your input on that. What do you say?
Yeah, gosh. I mean, so, full disclosure, I'm a paleoanthropologist in training, so I'm a fourth-year PhD candidate. But yes, I do make it my business to know the majority of creationist arguments and how they pertain to my field. And since I do study paleoanthropology, keyword paleo, the dinosaur soft tissue sort of dips a toe into paleontology generally. And I find that as an argument, it relies on, typically this is like a classic creationist thing, right? But two main ideas. And the first is misrepresenting what the data says. And the second is like conflating terms, right? So we're not talking about the same thing when we say soft tissue versus when young Earth creationists typically say soft tissue. But moreover, from there, they conflate further still. So, gosh, I mean, I think we should start with what is soft tissue, right? What do we mean when we say that? And I think that for that, you kind of have to start with the history of like when and where all of this played out, right? So Mary Schweitzer is the name that comes up all of the time because she was the sort of, front woman on the soft tissue in dinosaur bones, and indeed the front runner on soft tissue in fossils generally. And she did a lot of this work in the early 2000s. She was Jack Horner's former student, former graduate student back in the 90s. And effectively, what she argued is that if you have these fossils that are extremely well preserved, and you look inside of these fossils, you can find the remnants of soft tissue, right?
Blood vessels, soft and gooey inside. That stuff breaks down at the molecular level in a few hundred years. Yet they're in dinosaur bones, documented by the evolutionary paleontologists themselves.
We are not finding, and this is like the core point of all of this, if you take nothing else away from this part of our conversation, let it be this. We're not finding squishy, soft red blood cells that are equivalent or analogous to their fresh counterparts, or indeed anything that died 1,000 years ago. And we know what red blood cells look like from things that died 1,000 years ago because we have them in the form of like Siberian mammoths that have been frozen. So we have something to directly compare this to. And what we're finding in these dinosaur bones, or indeed like Eocene mosquitoes, or any of these much older, tens of millions of year old fossils, are not fresh soft tissue. They are the chemically transformed remnants of what was once soft tissue, right?
Well,
So
let's draw an example of that. One of the creationist claims, and while Dutko didn't mention this, he mentioned this one sentence. They found dinosaur soft tissue, and so many creationists want to use that as the go-to to prove that dinosaur fossils have to be only a few thousand years old at most, because he wants to say that they only went extinct a few hundred years ago. But the list of things that they claim, I mean, they say that they have found blood vessels, red blood cells, hemoglobin, bone cells, oval albumin, chitin, unmineralized bone, which was an interesting claim, collagen, limited DNA, pigment or skin pigments, keratin, fluoride export proteins, histones, and elastin, all in dinosaur fossils.
So, I mean, yeah, so first of all, you're not going to be finding chitin in dinosaur fossils. Chitin is something that you find in arthropods. So that should be alarming right off the bat that we're not, like, the guy who's speaking on this doesn't actually know what he's talking about, right? He doesn't know his way around the terms. That's a great way to know whether or not you should trust what someone is saying. But like, no, we don't find red blood cells. We've never found red blood cells. Again, we find the chemically transformed remnants of red blood cells. And, you know, friend of my channel, at least Joel Duff, has been a great watchdog on all of this. He's got what's called the hemoglobin challenge, where he's been charting creationists completely mismanaging this soft tissue claim over the past just year. And he's gotten so many people who come up, you know, Brian Thomas and James Torr is one of them, and he should know better being a chemist, but they come on and they talk about how, you know, you get these squishy red blood cells. No, you don't even have hemoglobin, right? They're not finding red blood cells. They're not finding hemoglobin. They're finding heme maybe, right?
And that's one of the few things that I know about this. I know that heme is the iron-based molecule on which the red blood cells is based. Because iron is already a heavy element, then it's not likely to be replaced in the fossilization process. And I did find a study that says that hemoglobin crystallizes very easily, and in crystalline form, the stability of the protein may be enhanced. The stability of the core porphyrin ring may also contribute to the longevity of this biomolecule. Hemoglobin fragments containing antigenic components have been identified in fossil bone up to 4,500 years old, and blood residues bearing antigenic properties have also been isolated from stone implements up to 100,000 years old, which falls way short of dinosaurs.
Yeah, I mean, it's really quite simple. We're not finding red blood cells or hemoglobin in any dinosaur bone ever. That is not something that has happened. And again, people who are watchdogs on this have charted just how many creationists are falling into this same trap. And it's because they never consult the primary literature. I mean, like Mary Schweitzer, again, the one who they love to cite, the one who is a Christian and who is not pointedly a young earth creationist, has laid this out in papers as recently as 2019, not just the blood claim, right? But none of the soft tissue that we find is in its original form, as it should be if these critters died roughly 4,400 years ago. Some of them, any of them, right? But that's not what we find. We find extremely chemically altered remnants, echoes, whispers of what once was present.
On that point, I had the opportunity. I managed to convince Schweitzer to do an interview with me, although she refused to be on video. She did it over a telephone. She said it had something to do with being old-fashioned. But okay, whatever. But at least I got an interview with her. And on the claim of unmineralized bone, she said, first of all, that bone can never be unmineralized or it'll become rubbery. And he says that she's aware of the particular fossils that in Madagascar that these creationists were claiming look like just white bleached bone that you find on the surface of the ground, and that it was effectively the same. She says that those items did look like bleached bone, but they don't feel like bleached bone, nor does it act like bleached bone, meaning that it's chemically different. As a result, she explained of the geochemistry of the depositional environment. After that, the interview got a little weird because she couldn't or wouldn't distinguish when a fossil of a bone is no longer the original bone.
So to her credit, that's actually...
If you could help out with this, that would be helpful, because she's saying that a fossil of a bone is still the bone. And I was confused at that.
So that's actually a really hard number to put, I actually found, because I was trying to find that number for enamel, because enamel is the most long-lasting of any of the sort of biological components of an organism. And the reason is because it's heavily mineralized already, and the process of fossilization is permineralization. So enamel doesn't go under as many changes, actually, to reach its sort of final fossil form. So I'm not sure what she means when she's saying that. My guess would be that because bone is already heavily mineralized, to pick a point when it's fully mineralized would be almost arbitrary, right? And then it would also be difficult because it depends on whether you're looking at cortical or trabecular bone, cortical and spongy bone. the compact versus spongy bone, or like which types of animals you're looking at as well versus an exoskeleton. So I'm actually not sure on that, but it ultimately doesn't matter, because the difference between brand new bone versus bone that is fully permineralized is trivial when we're talking about 4,400 years of time, right? It should not be permineralized really at all. You should be able to find one dinosaur bone that is fresh, that is, like the mammoth bones that we can still pull DNA from today, mammoth long bones, cave bear long bones, whatever. You should be able to find one that hasn't undergone this full complete process, but we don't. We don't find anything.
The confusing thing is when she says that it's still bone, when is it not bone? And I'm thinking, well, didn't you already answer that when you said that it behaves chemically different from bone? So
I mean, I don't know what she could possibly mean there, other than it's like the permineralization, because bones are already mineralized, that it's going to be difficult to draw a line there.
Yeah, I think the issue was that she was not wanting to be confrontational. And the points I was trying to drag out would have been.
I empathize with her on that, because I know she's been like thrown in the middle of a lot of this stuff, even though she's taken some, I would say, really strong stances on, like, she's sick of creationists, young Earth creationists using her work against her. The work that she's done, insofar as I've looked at it, is extremely robust. She's had a ton of people on it, secular and similarly religious alike. And I think it's very telling that she has not collaborated with or really commented on the work of young Earth creationists who are trying to make these types of claims, like Mark Armitage. I don't know what she thinks about that, but the silence to me speaks louder than anything else, because Mark Armitage is this one creationist who's coming out and saying that he's found just oodles and oodles of like brand new fresh tissue that he thinks you could still culture. Be my guest, my friend, but the second you culture it, we're going to know for certain that what you have is not dinosaurian in nature. But I think the core point of this, right, is that creationists make their claim on the sort of presupposition, if you will, that organic tissue or organic compounds, molecules, whatever, can't last that long. Therefore, they must be young. That's the basic thesis statement. But that's not true, right? Oil is organic. We have oil now. No one has ever disputed the fact that oil itself is an organic compound that we utilize. That's not controversial in mainstream conventional science. So why couldn't it be that you can have the remnants of organic compounds that make it to today from, say, 66 million years ago? And in order to make that case from a conventional standpoint, what you need to do is have experimental support. And so that's what Schweitzer and colleagues did. My favorite experiment to this point is, like, right after all of this happened, she was like, okay, all right, let's see, like, what we can do here experimentally. How can we test which elements influence how long things can preserve? And she recalled the role of iron and cross-linking specifically in things like formaldehyde and like tanning leather. And she thought back to this presentation that she had seen on the influence of free iron, like on living cells. And what free iron does is it induces cross-linking. So chemically, cross-linking sort of unravels these bonds and then reassembles them into this super rigid but like kind of functional mess of organic tissue. And so what she did was a very elegant and simple experiment. She was like, if iron plays a role in preservation in these biomolecules over long periods of time, then we should see that if we expose living tissues to it. So she took an ostrich femur, cracked it open, got some blood vessels from inside the ostrich bone, and submerged them in two different types of substrate or of solution. One's water-based, one has free iron. After 3 days, the water solution had these blood vessels in this slurry, like a mess. Bacteria, natural autolysis, like all sorts of things that degraded the blood vessels to a mess. After 2 years, the iron solution had not changed. The blood vessels in the iron solution had not decayed at all. There was no appreciable amounts of decay. This is in her paper, right? I believe this was a 2009 paper, if memory serves. What that suggests, right, is that iron increases preservation time by at least approximately 243 days, at least. Now, keep in mind that at the end of those 2 years, decay hadn't started. So really, this is going to be significantly more than that, on the order of, if we scale it up, if decay starts at the end of those 2 years and we scale it to the 3 days, like 900 plus times over. And all of a sudden, iron and cross-linking are like a very elegant means by which you can preserve like chemically altered versions of original biomolecules. Under a conventionally scientific time frame, though, we should still see scaling, right? As we look across the geologic column, as we look across geologic time, older things should, even in these biomolecules or biomolecular remnants, be more degraded and appear older than newer ones. And that's precisely what we see, whether we're looking at dinosaur bones or whether we're looking at tooth enamel in hominins, right? We see this scaling. How is the flood going to do that, Aaron? How is the flood, which preserves these things in a single year 4,400 years ago, going to scale it not just with geologic time, but down to the radiometric dates in the case of this hominin tooth enamel study that I've got? Like, that doesn't work. So they have to have a mechanism, if you're a young Earth creationist, to explain why, when you crack open a dinosaur bone, you're not getting bone that you can pull DNA from like you can with cave bears and mastodons and the Pleistocene mammals that, from a conventional standpoint, did live just thousands of years ago. Why can't we pull the same stuff from dinosaur bones? Further, why is there a difference between dinosaur bones and Permian synapsids and Cambrian trilobites, or Cambrian trilobites all the way up to the recent past?
And why, comparatively, are there such strong similarities between the vascularity of a Tyrannosaur and that of an ostrich?
Not just that, Schweitzer argues that the protein, the collagen that you can pull, that you can actually run, really basic molecular studies on that. And so that was actually done. And the T-Rex was closest to a chicken from their comparative database. So it's really convenient that creationists will say, yeah, look at all this soft tissue. It's so soft and fresh that, you basically crack open a T-Rex and it's oozing blood all over the place. And then they neglect to mention that it confirms the relationship of dinosaurs to birds, right? As these archosaurian theropods, right? So I mean, it's cherry picking as usual. It's misrepresentation of what is true and cherry picking what isn't, or rather, misrepresentation of what is or isn't true, and then cherry picking what certainly is. And it results in this complete mess. I mean, every single time I, or someone I know, Joel Duff again is a great plug here, have gone into these claims of, oh, they found chitin, or oh, they found red blood cells or bone cells or whatever. It's never, not once, been like the living version, or the version that it should be if it died just 4,000 years ago. It's always chemically altered, and it's always like a whisper of a ghost of a chemical remnant every single time.
I had a question about, on this list of things, when they said limited DNA. There are people that claim that limited DNA, along with all these other chemicals, chitin and so forth, have been found in dinosaurs. But when I look it up, I see that the two oldest examples of DNA yet recovered were both found in Greenland permafrost. The oldest identified DNA is from a mammoth's tooth dating to 1.2 million years ago. And then there's unidentified fragments of genetic material that are also found in the same sediments, but or in Greenland permafrost sediment, that is twice that old, at 2.4 million years. But nothing about dinosaur DNA. What are they talking about when they say that there's been limited DNA found in dinosaur fossils?
Honestly, the only thing that I can think of is that that's coming from Mark Armitage. I'm unaware of any DNA work that has been like comprehensively done and published like in the literature. It's possible that I've missed something. I'm not a biochemist, I do paleoanthropology. But I'm unaware of any of that in existence, like being the case. I don't know where they're pulling it from. I mean, at least with the others, you can point to the study, right? Like they'll point to eumelanin being found in like ancient squid fossils. And it's like, yeah, again, chemical remnant of what used to be ink. Sure.
Yeah, I think I saw that same study that was explaining how both keratin and melanin can be fossilized, but only rarely, and again, under specific conditions, just like when we find bacterial microfossils.
Well, right. I mean, it's outlined really nicely in Fuzz Rana's book, Dinosaur Blood and the Age of the Earth. He's an old Earth creationist, so I agree with him. I disagree with him on a lot of stuff, but he's a biochemist, and he makes an excellent case in a book that was written like many, many years ago now. Even when it was written, he makes a phenomenal case that it's really curious that all of these, again, chemical remnants of older biomolecules, why are they all the most robust types? Right? Why is there such a heavy bias towards collagen and keratin and chitin? Why aren't we seeing these more, these less robust biomolecules that we can and do find in like frozen mammoths, right? Creationists might point, gesture at that and say, oh, well, it's about the conditions, right? The Siberian mammoths and the Siberian horse that was frozen and the cave lion and whatever. All of those guys have been frozen solid. They've been flash frozen. They're not waterlogged, whatever. That's the reason for the discrepancy. But again, I point to the time discrepancy in material that has fossilized or preserved under similar conditions. And we still see this time bias, no matter how you look at it. How do you explain the time bias that isn't just like tightly correlated with the geologic column, right? But that is tightly correlated with radiometric dates and other fauna that we associate and can date using paleoenvironmental clues.
So all these things are supposed to have gone extinct at about the same time, right? I mean, post-flood, I mean, they're like Andrew Snelling and other creationists, other young Earth creationists argue that the entire fossil record is the result of the flood. So dinosaurs, mammoths, everything, they should all be buried at the same time. But then why is it then, as you're saying, we had that great story from the 70s about an expedition into to the North Pole where they happened across a frozen mammoth, and all these guys are starving, and they were actually able to eat a 10,000-year-old mammoth. Now, I don't know if the story is true anymore because it came from the 1970s, and I found out a lot of stuff that we saw in the news back then never really happened.
Well, I'm left wondering why we can sequence the genome of a mammoth, why we can sequence partial genomes of organisms that weren't preserved in the Siberian permafrost, that are in similarly not necessarily arid but more temperate conditions, stuff that dinosaurs would have been in, that shouldn't have that same bias, or that should have sort of the same paleoenvironmental conditions as these dinosaurs from a creationist standpoint, right? Why can we sequence the genomes or pull genetic material from stuff that is conventionally from the Pleistocene, but not from Mesozoic animals if these guys died at the same time 4,400 years ago? That should not be the case. That bias should not exist, but it does.
Yeah. My suspicion is that the young Earth creationists making all these arguments, doing all of this apologetics, I have a number of clues for that I don't want to get into right now. Things that some of them have told me in person, but I've divulged some of that in earlier videos and such. But my inclination is they know they're full of shit. They have to sell a story, either to make a living or to maintain an illusion that they desperately want to pretend, even if they know it's pretend.
Well, chemically altered remnants of biomolecules doesn't sell or elicit the same mental image of a young Earth as we cracked open a dinosaur bone and found fresh blood vessels and squishy red blood cells. It just doesn't. And what's interesting to me is how they've sort of evolved, if you will, or rather how they've undergone stasis over the past 2 odd decades since this stuff first started coming out in 2004. I mean, Schweitzer has put her nose to the grindstone along with many other paleontologists generally, and folks who do paleogenomics, and come up with these wonderfully experimentally supported mechanisms for preservation of these highly degraded, chemically altered biomolecules, right? The free iron hypothesis is one of them. That's the one Schweitzer likes. But there's another one that's, I think it's called the toast hypothesis. I have it around here somewhere. The toast hypothesis is like the sort of fun version of it. But the second hypothesis is called the advanced glycation and lipoxidation end products hypothesis, the AGEs, ALEs. And we call it the toast hypothesis. And I believe that the individuals that propose it are okay with that as an idea, because it effectively chemically works similar to how you get the black layer on the tip top of your toast. That is like much hardier, much more rigid. It's hydrophobic. It's bacterially resistant, and it basically almost hardens, it calcifies, for lack of a better term, these biomolecules into a state at which they, again, are chemically altered from their original state, but they preserve it significantly longer. And then Landon Anderson comes along in 2023. I think it's Landon Anderson. And he synthesizes both these hypotheses into a single chemical pathway. So he takes both hypotheses and says, no, these aren't even competing hypotheses. They're basically two steps of the same chemical reaction. And he puts two and two together. And so now we've got this wonderfully elegant means by which to explain the preservation of these chemical remnants within things like Mesozoic dinosaurs or Eocene mosquitoes or whatever. And we can also explain the discrepancy between older and younger preserved biomolecules. And you might be wondering, well, what do creationists do when they see this? Well, Brian Thomas has, and I'm going to say this because this is the only way I feel like I can say it. I think Brian Thomas's response has been to lie about it, because his most recent publication, I think it was in ICR, he directly says that what we're finding in this fossil material is not chemically altered, right? Like his direct quote talks about how we're finding like original material that is not chemically altered. Schweitzer can be quoted in all of her recent papers as saying we've never found one that isn't chemically altered, but it's the only way that he can hand wave it, because his way of hand waving that 2023 paper is saying, yeah, but that 2023 paper by Landon Anderson results in chemically altered biomolecules, and that's not what we see. But it is. It simply is. At least that's what the people who are doing the actual work are saying. So, unless Anderson, or not Anderson, excuse me. So unless Brian Thomas, has some material that isn't chemically altered that he would like to share with us, I don't know how else I can interpret that as other than like being dishonest, because he's been on this subject, since the very beginning.
So like you said, with DNA and with chitin and a couple of other things, the claim is that we're finding all of these things in dinosaur bones, from fossils from millions of years old. And the best that I've been able to find is, where we found this or that from 4,500 years ago, which is hardly in the same range, and certainly not, specifically not from dinosaur fossils. So the one thing, when I look up proteins in dinosaur bones, the one that I saw where there's like one listed, we have found collagen, and they'll say that one is a legitimate claim. They actually did find collagen in dinosaur bones. And I remember you doing a presentation on this where you were talking about how collagen is, one, surprisingly durable, and two, can in a sense be reconstituted.
Well, yeah. So you have this process under, again, the iron preservation model, under this free floating iron, which you ask yourself, where do you get all this free floating iron when a critter dies to instigate this preservation? Well, we have tons of iron in us. That's why our blood is red, right? Our hemoglobin is what's keeping that iron in check, because free floating iron is really bad for organisms because, and again, I'm not a biochemist, so this is my sort of layman's understanding, it effectively induces cross-linking, which is really, really great if you want a stable molecule, but it's really, really bad if you need flexible molecules that are capable of doing important biological processes. So when you die, right, a lot of the mechanisms that sort of maintain your biochemical integrity and homeostasis, a lot of those quit. And so that iron goes from being trapped in your blood to being loose and available, for lack of a better term. And it can induce under very specific conditions, right, this cross-linking. What cross-linking does is when you've got polymers, which they're these like long strings, like they string-like molecules, the polymers of collagen are already in a triple helix. And what cross-linking does is it effectively starts to bind them along the polymer as well. And so you get this like sheet, for, again, lack of better terms, of collagen that is a lot more stable and robust than any individual like collagen polymer would be. Now, if you can imagine that you've got these polymers all laid out into a sheet, as they sort of degrade, if they're exposed to the proper chemicals, they're already in a lattice. They're going to reconstitute themselves, right, over and over and over again. At least that's my understanding of how the reconstitution works. I don't even think you need it, though, right? Like a lot of the time, I remember saying that was a presentation from quite some time ago. But the nature of this cross-linking is that it is so incredibly stable that, again, when it was done experimentally, after 2 years, we saw no decay in these ostrich blood vessels. None. That's 243 times longer than the one in water solution, just because of this free iron. Now, collagen is like notoriously robust as a biomolecule, but so is chitin, so is keratin, so is eumelanin, so are a lot of these other specific types of biomolecules, all of which are known for being robust, all of which are the only types of biomolecules that we find, again, traces of in these fossils. So at the end of the day, like you've got this wonderful preservation mechanism that explicitly works with this particular biomolecule that I think does a great job of explaining why we have soft tissue.
So there's only a handful of molecules that are this robust and can be, although usually not, but can be preserved under very specific conditions. If everything falls into, if everything is right, if it's a big bone, it's an interior, it's insulated in the interior of the big bone, it's deeply buried, and all of these conditions are just right, then you might get fragments or traces of mineralized shadowy remains of the original thing.
Yeah.
That may be for collagen, which technically is the original thing because of its what was it, your triple helix construct.
But it's not the original thing. That's the thing. It's been chemically altered. Even the collagen is not original. Now you can say that the chemicals themselves, right, like the atoms are original, sure, but it's been chemically altered. All of them have been across the board. When we're saying original material, again, that's something that we have to be really clear about with definitions. Do we mean original as in literally the same thing, which is how creationists are proposing it, or do we mean original as in chemically it's the original stuff, but it has been chemically altered to withstand and persist, and that's why we have it. Those are two different animals that I think is an important distinction to make.
Thank you very much for that, Erica. I don't think we have anything else to cover. You've been very, very helpful, and thank you for coming on.
I'm glad glad to see it. I mean, I'm glad to be here. Again, I'm not a biochemist, so I'm sure I'm going to get nicked for terminology here and there. I hope I've explained it in a way, I tried to explain it in a way that a layman like myself understood it. I've been reading the material about this for quite some time, and I've been trying to refresh myself on it as of late. I want to plug all of Schweitzer's work here. Landon Anderson's 2023 paper is phenomenal in how it integrates these two hypotheses.
Can we put links below to both of those?
Yeah, of course. I have them all handy. I want to encourage everybody to do one thing when it comes to this dinosaur soft tissue claim, or like any soft tissue claim. Just go to the source material. Like it's that easy. You can see it in the abstract. Oftentimes you don't even need to have access to the full paper. Or if you're really curious, email the author and say, hey, what exactly did you find? Like what precisely was found in these fossils? It won't surprise me if we find out that some degree of chemical preservation isn't that uncommon. But what will persist, at least insofar as I understand how biochemistry and preservation works, is that you're not going to find like super fresh red blood cells. I'm sorry, I should just say you're not going to find red blood cells in any of these, like original red blood cells. It's not going to happen. And it hasn't happened. And I think we need to be more vigilant in correcting creationists when they say this, because they're not just misrepresenting the science, they're misrepresenting people's hard work. I mean, Schweitzer put her career on the line to make the case in the first place that you can have preservation to some degree to this end. And what does she get for it? She gets a bunch of ding dongs who are misusing her work and making her look bad. And I'm sure she doesn't appreciate that. I certainly wouldn't.
And all of this is supposed to prove that the Earth is young, when the irony is that she herself was a young Earth creationist when she started working in that lab. And now, while she says still a Christian, she is an old Earth evolutionist now. So it must be maddening for her to see the very information that changed her mind that the Earth is old being used to convince the gullible that the Earth is young.
Right. And it's not even her work, right? It's a bastardized version of her work. And I think
No, but she gets cited all the time.
I know. And it's not saying what people think she's saying. I encourage people out there, again, like just go to the original source, see what was actually found, find out if it's actually original material, as the creationists are often making it seem, or if it's something new. And I encourage the creationists to, if you're out there, right, if you have a problem with some of these preservation mechanisms, and what they love to do is they love to say, oh, the preservation mechanisms are like a rescuing device. No. When you have an open question in science, you try to make sense of the data in the light of natural processes, how the world works, and use big S science and the scientific method to suss it out. I get that they're mad that two separate mechanisms that are complementary to one another can result in extended preservation, but honestly, if I were them, I would focus on trying to explain why we have the discrepancy in super, super old stuff, even by their sort of timeline, and super, super young stuff. Like, why does that exist? So fix your own model, and then maybe come and try to poke holes in our conventionally scientific model. But needless to say, they've got their work cut out for them.
Thanks again.
Of course.